Hello, welcome to this overview video on Project Peregrine, which is the first phase of Falcon. And in this video, I'm trying to explain the organization of files and the directory structure in Falcon. Falcon, for those of you who don't know, is a module within festvox. Festvox is a suite for building speech synthesis systems. And let me start with a very brief lookup of what festvox and how its organization is, and then we'll dive right into Falcon. So, as I mentioned, festvox is a tool for building speech synthesis systems. Most of the code base that we probably will be using is the directory src, which is short for source. There are a lot of directories in this subdirectories in this directory. For example, this one, Interflies, was built by um, my advisor Kishore, which is essentially towards aligning long audio to long text. There is another module called SpanF0, which is a prosody model built by a previous student called Gopala. Voice conversion built by Professor Tomoti Toda, etc. So specifically, I'm going to talk about Falcon because I'll be using that a lot during my PhD. And Peregrine is essentially the phase one, which involves a lot of development of Falcon. And phase two and phase three, we'll get to them later. So here is a brief overview of the GitHub page of Falcon itself. Falcon, it is within Festival, but it also has got quirks from Kaldi. It uses some of the implementations by Ryuichi Yamamoto's Tacotron repo, which I found quite inspiring. So here is how it's organized. We have three basic building blocks. The first one is called layers. Layers essentially build onto blocks, and blocks build onto the models. So I've presented an example here. For example, WaveNet is a model. It's built using dilated residual causal convolutions, and these are the blocks. Each of these blocks is built using convolution layers, and that's a layer. So let me give another example. If we go into this layer, one of the first classes we see is something called sequence-wise. All this is doing is trying to apply a sequential operation on its input. A typical uh, a typical example would be applying on a linear layer, for instance. So let's say we have output from an LSTM and we want to apply the linear layer out on the output of the LSTM. Then directly using a linear layer applies it only to the last layer, only to the final output. Whereas if we want to apply it to every time step, then this is a useful function, and I use it to I wrap this around linear function and use it. There are other use cases. For example, if we define custom loss function and we want to calculate per time step, then it's very useful to wrap it up in sequence wise and apply it there. So this is an example of a layer, and layers build on to blocks. An example of a block is either an attention module or a prenet module, or CBHG. For those of you who are familiar with speech synthesis tachotron framework, CBHG is a module introduced in the paper Tachotron, first generation of Tachotron, and that is essentially a block. There are other examples like residual convolutions, etc. And then models use both blocks, and by design they also use layers. For example, Tachotron 1 is a model. You can see these are implemented in typical Python class structure, so we can extend the classes, define some other things as an extensions to, etc. So the web page, all these GitHub page has a README which also lists some sample examples, which you can check out to see how the current implementation goes.